Our chosen topic is autonomous vehicles, which was done by Vrihi, Renal, Ria, Lauren, and Jeffrey.
Okay. Ready?
We're going to start off by mentioning an overview of the information system and information technology of autonomous vehicles. Basically, an autonomous vehicle describes a vehicle that includes a collection of individual technologies that enable tasks to be performed with little to no human intervention. It also requires a range of technologies to sense and monitor the behavior of its external environment and to act where required. It must have the capacity to prepare the more extensive surroundings to key ITIS components that help the car's perform its functions properly include a variety of sensors that are used to allow vehicles to accurately depict their location. A data processing component is used to interpret relevant information and manage computer-to-human driver interaction. Mechanical control systems are utilized to the vehicle to perform the desired actions. There is also communication and networking, which includes vehicle-to-vehicle, vehicle-to-infrastructure, and pinpointing location. And smart technology infrastructure provides a feedback loop of data to inform optimal decision-making. Here is a not-so-brief history on how autonomous vehicles came to be. It all started in 1500 when Leonardo da Vinci was credited with the world's first robot, a self-propelled cart he created that used springs to provide power. Then, in 1958, cruise control was invented, which allowed for a constant set speed and a smoother ride in cars. Moving on, the lunar rover, the cart, was created and equipped with cameras programmed to detect a white line on the ground and follow it to the moon in 1961, avoiding the 2.5-second command delay a remote control rover would have had. Later, Tsukuba Mechanical created a passenger vehicle in 1977 that traveled close to 20 miles an hour and was equipped with 2 cameras. And Carnegie Mellon's began research on computer-controlled vehicles in 1984 and produced their first car, NavLab 1, in 1986. After that, the Eureka Prometheus project became the largest driverless car research and development project and ran from 1987 to 1995. 749 billion euros funded the project that many universities and automotive manufacturers collaborated on. In more recent news, in 2013, VisLab introduced an autonomous vehicle that can move through traffic on a public street. And by the end of 2015, Nevada, Florida, California, Virginia, Michigan, and Washington, D.C. consented to the testing of fully autonomous vehicles on public streets. And also, Tesla released versions of software in vehicles that allow cars to park themselves when unmanned. All of these events led up to the first fatal accident involving a self-driving car that was reported on May 7, 2016, when a Tesla electric car failed to brake and continued to travel after a tractor-trailer pulled in front of it. Tesla Motors stated that neither autopilot nor the driver noticed the white side of the tractor-trailer against a brightly lit sky, so the brake was not applied, and the car attempted to drive in full speed under the trailer, with the bottom of the trailer impacting the windshield of the Model S. By this, we can conclude that this was officially a human error. Here in this chart, you can see where the autonomous vehicles created an era that fits in with the following internet and social media eras. Next up, we're going to talk about the relevant technology in the IT and IS components. As briefly mentioned before, an autonomous vehicle will include a set of technologies which enable vehicles' performance with little to no human effort. On the next slide, we will go over a set of in-vehicle autonomous technology, their purpose, and technical necessities. Ready?
Yep.
In this chart, you can see the required features and their purpose for appropriate function of the autonomous vehicles. It also shows what technical or ITIS related features that play into parts. For example, first we have the driver monitoring system, which includes sensors, cameras, eye tracking software, and a braking control system in order to supervise driver alertness and provide warnings. If overlooked, the vehicle will brake. Next up, we have the adaptive cruise control, which uses sensors, radar, LiDAR, braking, and throttle control systems to assist driver by controlling speed by assessing distance from other objects and controlling braking. Another interesting feature includes the collision avoidance system that uses sensors, lasers, braking, and throttle control systems in order to warn the driver when there's an impending crash that may take over controls. One last one I'll go over is the Night View Assist System, which uses high-resolution liquid crystal display and image processing for assisting the driver in seeing.
I'm Priscilla,
Here's a short
one of the
video
test drivers
of
on
how
the
the
Google self-driving
self-operating
car
car that is being
Our
tested
team is
by
responsible
Google
for keeping the
actually
cars
works.
and other people safe while on the road, and for providing feedback on how they perform in the real world. A big part of our job is to go out into the world and uncover all the potential scenarios that a car might encounter. Then we help the engineers teach the car how to best navigate each one. Here are some examples of situations that we regularly encounter on the streets of Mountain View, California. We've taught the vehicle to recognize and navigate through construction zones. Our sensors spot the orange signs and cones early to alert the car of the lane blockage ahead, and we can change lanes safely. You'll also notice the vehicle typically moves to keep a safe distance away from large obstacles, like this truck stopped on the side of the road. Now we're approaching a railroad crossing, which requires special care. Notice the red fence and railroad sign that appears to the computer as we approach the intersection. This means that we'll wait until the tracks are clear of other vehicles before proceeding. Our cars treat cyclists as a special category of moving object. Watch in this example, when the cyclist holds up his arm, our software detects the hand signal and predicts his movement into our lane. The car knows to continue yielding to the cyclist passing by, even when he changes his mind, multiple times. We still have more work to do, but it's fun to see how many situations we can now handle smoothly and naturally. See you on the road. We still have more work to do, but it's fun to see how many situations we can now handle smoothly and naturally. See you on the road.
Now we will talk about some of the business models and uses. There has been speculation that autonomous vehicles are the next radical market transformation for the automotive industry, as cloud computing was for the software industry. Big companies like Uber, Google, and numerous major automakers are already working to bring autonomous vehicles to the marketplace. In October 2016, Tesla declared that 3 of its models would be built in with all the hardware required to be driverless. And in September 2016, Uber cars were seen on the street in self-driving mode. As we can already see, the technology is rapidly maturing, and we continue to see testing of cars with driverless capabilities in some cities. Now let's talk about the possible business models. There can be 6 different models of autonomous vehicles usage that can and perhaps will coexist. Let's explore them. The first one we have is the true ownership model. In this model, a consumer buys a car in the traditional sense. In this case, however, the car drives itself into the consumer's driveway. During and at the end of the payment period, the consumer owns the car and remains responsible for all the maintenance, insurance, and upkeep for the car. Second, we have the traditional lease model. This model acts for an entirely existing business model. A consumer leases the car for a term of years and is otherwise responsible for all costs and ownership. Next up, we have the exclusive license model. This model is the initial move towards transitioning to an alternative method of consuming private transportation. In this model, The owner of the vehicle is not an everyday driver, but they control where the vehicle is stored when it is not in use. Thus, the responsibility of the car is handled by the true owner, not the user. This way, the car will feel personal to the user, so they can store their belongings within the vehicle, such as a car seat or a personal phone charger. On the other hand, the user will benefit from no extra or unpredictable storage and maintenance expenses. Number 4 is the non-exclusive license model. This model is like the exclusive license, except the users of the car have little control on what happens inside. The time frame that the consumer will have use of a vehicle would fluctuate daily, monthly, yearly, or some longer term. Through a non-exclusive license, the vehicle could be shared by multiple people within multiple periods of time. This could be a useful model for an extended family. Resource consumption could be enhanced in this non-exclusive approach because one vehicle could be used multiple times throughout the day by different but unknown individuals. We also have the fleet-owned service-based model, which is a service model that would be like one of a taxi or an Uber. The user can either pay by the ride or rent it for an indefinite period of time. In this model, the user has zero control over the car because it is owned, stored, and maintained elsewhere. The user consumed transportation on an as-needed basis. The vehicle is truly for hire, and the owner will attempt to maximize its usage across its lifetime. The owner is exclusively responsible for maintenance. The model may make the Uber or taxi driver become a thing of the past, as companies in this space may choose to own their own fleets of cars and will move to replace the driver with an autonomous vehicle. The last one is an individually owned service-based model. This model is a hybrid to models 4 and 5 above. For the user, it is identical to the service-based model, fleet-owned. But providers like Uber may ultimately decide to avoid the huge capital outlay involved in purchasing the fleets of vehicles. You purchase the car for owning it as a driverless ride-sharing asset, and the time that Uber taxi drivers currently spend driving is completely freed up for other purposes. With this method, you could basically be working 2 jobs and get easy money. While you're doing your actual work, your vehicle is out on its own to earn you some extra cash. Companies and individuals would most likely be using one of these business models, which could possibly have great opportunities for success. Now, let's explore some of the benefits of automatic vehicles. Self-driving cars will help keep traffic moving instead of having cars idling, which wastes time, gas, and money. Therefore, traffic congestion will be reduced. Research by AAA estimates that traffic congestion costs the U.S. economy around $100 billion a year. Productivity will be big gained at work due to lack of driving frustration. Traffic accidents will be dropped. In the UK, KPMG estimated that self-driving cars will reduce the automobile accident death to 2,500 fewer between 2014 and 2030. Shortly, we will have a look at some more similar results. Also, drunk driving will no longer occur. Additionally, long drives can go on all night without worrying about the driver's rest. The car could drop you off wherever you like to go, and then go park itself. And lastly, no more driver's license or driving tests. According to National Highway Traffic Safety Administration, there were approximately 5.3 million police-reported motor vehicle crashes in 2011. 2,217,000 of them were injuries from those crashes, and 32,367 were deaths. NHTSA research also suggests that 93% of vehicle accidents were caused by errors. On the other hand, here we have a few statistics that compare possibilities and outcomes of 10% self-driving cars and 20% self-driving cars. And as you can see, there are some drastic effects. Here, we will discuss some of the challenges faced from utilizing automatic vehicles. The investment needed to design and build these automobiles is not readily available, especially when the demands of basic road maintenance are pressing. Transition to new vehicles will take time. Per Kelley Blue Book, who conducted research using market intelligence in 2102 study, revealed that 63% of respondents wouldn't want a self-driving vehicle. In the United States, only 4 states have legalized use of autonomous cars, with a few states currently considering similar legislation. Human decision-making will reduce and be replaced by technology. Many traffic control and accident repair jobs will reduce tremendously, causing many people to be left unemployed, especially truck drivers and taxi drivers that will lose their jobs. Reading human road signs may be difficult for a robot. Self-driving cars could potentially increase crime such as terrorism, as they could be loaded with explosive and used as moving bombs. Next up, we're going to talk about the future trends. As we already know, self-driving cars are no longer a futuristic idea. In fact, some companies, such as Mercedes, has already released some self-driving features. Tech companies are also pioneering their first self-driving cars. As we previously mentioned, Google's self-driving car project. Google also announced that it would be testing their driverless cars on roads of California in the upcoming summer of 2017. As you can see on the graph, by the end of the forecast period on the chart, it is estimated that 10 million cars will be on the road with one of the autonomous features. And because of rules and insurance questions, user-operated fully autonomous cars will come to the market within 5 years, while driverless cars will take a longer time. This slide briefly shows how these automakers are already planning to adopt to the automated vehicle technology. For example, we have Nudemy to provide self-driving taxi services in Singapore by 2018, and it will expand to 10 cities around the world by 2020. Ford is providing fully autonomous cars by 2021. Here we have a list of other brands of cars that are providing autonomous vehicles. We have the Volkswagen, which announced that they would have it by 2019, BMW by 2021, Toyota by 2020, Tesla by 2018. Cars will be in use all over the world by 2025, and by 2040, 75% of vehicles will be autonomous. It is very surprising how close we are to a car revolution.